Alright, so I made this little program in SDL. Um, Basically, it's just like a 3D renderer. Um, this is a really wide FOV. This for some reason is like kind of inverted. Like the smaller it is, basically the wider it is. But it's basically just because that's the distance from the center. So right here, if basically once this gets smaller, it's going to be a larger quotient or answer to the division problem right here. It's going to approach 0 basically. But actually I can probably try changing that. Let's do like 360. I think 360 looks pretty normal. Okay, yeah, there we go. Actually it's too normal. It looks almost like isometric. Okay. Basically this is just the distance. The FOV right here is just the distance between the center of the cube, or like 0, 0, 0, and the camera, I guess. So right here I have a pointer of 3D coordinates. It's just defining all the vertices. I'm storing it in a vector. And we're taking the FOV as the input, like right here. We're converting it to an int and setting it as the FOV. Then we create a 3D coordinate for the center, because we have to know what we have to rotate around. In this rotate class, we have to know what we have to rotate around, so that we can calculate. Basically, we're just moving this to 0, 0, so we don't have to like do all the adding and subtracting the coordinates, because on the actual render, this isn't 0, 0, this is, so we have to move everything like over, and that's basically what this does. And then we just set the background to black, and then we draw all the lines within a distance. This is basically just a safe distance between two horizontal points. Actually, let me do like a really big delay, like a second. No. So it's basically just the distance between these 2 points instead of like these 2 points. So the edges between the edges instead of the diagonal vertices, I guess. I don't know what to call them. The thing with this is it takes a while to escape. Okay, let's set that back to 16. The reason there's 2 for loops here is because I want to iterate over every shape or every vertice. So basically it connects all of these to all of these, and this one to this one and this one, or like all these. Basically it connects every point to every other point. It's kind of inefficient, but for this little cube it's not really going to make a difference. And then these I and j are basically just the indices of the shape, or the vertice in the shape vector. Then we check if they're not equal to each other, so we don't want to draw a line between a vertice and a vertice that are the same, because there's no point in doing that. It's not going to show up. Then we just draw the line within a distance. We define the start. We I don't know what this is called, but basically we just get the value instead of the actual reference to it, to the 3D coordinate, because this line within distance, it basically just takes the value instead of an actual pointer, because I didn't want to use pointers all that much. Because I made a few other programs and pointers were just a whole lot to deal with. Yeah, so basically this is a distance between, or I guess a safe distance, because for some reason 100 doesn't work, even though technically it is 100. Yeah, it's working now because I didn't recompile it. Okay. Okay, let's recompile. Okay, yeah, so basically it just doesn't draw anything because it's not technically within the distance, even though I set the distance between less than or equal to distance. I'm not sure why you have to add one. But yeah. Then right here, we're just listening for events. I press escape every time I close the window, which is right here. Key code 41. And then make it 60 FPS. This is very rough. I'm not using delta time, so it's not technically exactly 60 FPS, but my computer's fast enough to run it basically instantly, so it's basically 60 FPS, and then I'm just updating the renderer. And yeah, so the rotate 3D function works basically. I overloaded it 2 times so that it would rotate all of them within a shape vector right here, or I could rotate them individually. So I could pass a reference to the point. The reason I'm passing it to a reference is because I want to actually change the like position data instead of just returning a copy of the coordinates. And then you know what to rotate around. And then these are just technically they're the radians I'm rotating, but I'm converting them to radians instead of degrees because like all these sine and cosine take in radians. And then yeah, that's pretty much it.